Start by comparing these two triangles, and we're just going to make some observations. And so the first thing that I'm noticing is that all of the angles are congruent. So I see angle A is congruent to angle D, angle B is congruent to angle E, and then angle C is congruent to angle F. I'm also looking at my side lengths and saying, so all the side lengths of triangle ABC are multiplied by 2 to get triangle DF. It's fine. Something dropped. It's fine. Okay. And so what you're seeing here is actually called a dilation. Think about, if pupils get dilated at an eye doctor, they get really big. It's basically taking something and making it larger or smaller, and all of the angles are going to remain the same. So dilation so all side lengths of a figure are multiplied by what is called a scale factor, which we're going to represent with the letter K. And so because we're not doing anything to actually change, since the side lengths are going to get bigger or smaller, but since they're all maintaining that same ratio of enlargement or reduction, all the angles are going to stay the same. So our first question here, we're going to dilate each image given a scale factor and the center of dilation. We're not going to worry too much about the center of dilation, but we are going to worry about how to do it. Well, here's what you're going to see. We have what's called the pre-image and the image. A pre-image are coordinates before we do anything to it. And so that'd be like S is coordinate at -1, 2. R is at 1, 0. And T is at -2, 0. So that's our pre-image. The image is what happens after we dilate. And the new points are going to be called S prime, so that's with a little apostrophe, R prime, T prime. And so here's the thing, if I have to double everything, that's going to involve the X coordinates and the Y coordinates. And so with K being 2, I'm just going to multiply everything by 2. So to get here, we're just going to times it all by 2. That's my scale factor. And so S prime is going to give me -2, 4. And we can label that. R prime is going to give me 2, 0. And T prime is going to give me -4, 0. Ta-da! There you go. Something that I just want to point out as like a fun fact is that these points are on the same line if we were to extend them from the origin. So it's a way you can just check to see if you did it right, is that, oh, look at that, they're on the same line. We call that being collinear. So, fun fact of the day. Okay, so there's that one. I can multiply by 3/2. I'm going to come to part C. L is 2, 0. M is negative 1, 3, and n is negative 2, 0. So that's my pre-image. If I want to get to my image, okay, I'm going to dilate. We need to multiply everything by 1/4, aka multiply by the scale factor. So 2 times 1/4, and I can do that in my calculator. I should get 1/2, or I'm just going to put it at 0.5. Negative 1 times 1/4 is negative 1/4, which I'm going to put as a negative 0.25. And then 3 times 1/4 is going to be something I should know off the top of my head, but I don't at the moment. So there's no shame in typing something in your calculator. 3 times 1/4 is 0.75. Oh, yeah. Okay, and anyway, the last one, negative 2 times 1/4 is negative 0.5, and then 0. So I can come label those with half. There's L prime. And then got negative 1/4. Look at how cute this is. It's so small. And then negative half. Adorable. Okay. So if you were to find the coordinates of the dilation after the figure, like for each of these, it's the same thing, just multiplying by the scale factor. And so we're going to take all of these and multiply them by 0.5, which is just cutting everything in half. So I get negative 1, half, d prime at 1, 1, and e prime at 1, negative 1. Cool. Dilations. Okay, so based on these things, we just need to figure out what about the scale factor tells us if we're going to have an enlargement or a reduction. Well, when did it get bigger? When did it get smaller? I see part A, the triangle got bigger, part B, it got smaller. So what's the difference here in the scale factor? What I'm hoping you're realizing is that it's an enlargement if your scale factor is bigger than 1, and it's a reduction if your scale factor is less than 1. That's how we'll know automatically if it's going to get bigger or smaller. So find the scale factor from each polygon on the left to the right, and then state if it's an enlargement or a reduction. I might just start with that, just because you can tell by looking at it. If I'm going from left to right, 14, 12 to 24, 14, 21. Oh, see how these side lengths are getting bigger? So I know that's going to be an enlargement. So that tells me that my scale factor should be bigger than 1. Well, how am I going to find what the scale factor is? How do I know what to multiply by? Well, here's what I do. I think that I'm going to take... I know I need to multiply 14 by something. I need to multiply 14 times the scale factor, and that's going to get me to 21. I know those were matching up sides because I can just flip the one on the left upward, and then they're facing the same way. And so I know I just need to multiply 14 times the scale factor to get to 21. And so now I can just divide by 14, and that will give me the scale factor. And my scale factor here is, if I divide both 21 and all that by 7, I get 3/2, which is equal to 1.5, which matches up with an enlargement because that scale factor is bigger than 1. Okay, coming to my next one here, we're going from left to right. I already know that this is going to be a reduction because it's getting smaller, so that means my scale factor should be less than 1. And so now our job is to just line up our matching sides. And I can look at this, and to me it looks like the 120 is going with 36. Maybe, you know what? We'll come do part C instead because we're going to get to this idea a little bit later. Okay, once again, I see that this is a reduction. And so if I want to find the scale factor, the 20 is the shorter side, and so the shorter sides are going to line up together. I know that 20 times my scale factor is going to give me my new result. And so now I can just divide both sides by 20, and I get 0.25, which is a reduction. That matches up because it needed to be less than 1. So we're finding our scale factor through division. So all this idea of dilation and scale factors is pretty much the idea of similarity. For two figures to be similar, it just means a dilation has occurred. We're going to change the color because it's fun. Okay, and with a dilation, I'm just going to write down more things we know about dilations. Is that I'm going to say corresponding angles. So corresponding angles are congruent. And then corresponding sides are multiplied by the same scale factor, meaning that every length in the triangle or in the rectangle or whatever has been multiplied by the same scale factor. And that's our idea of similarity. So we have what's called a similarity statement, and that tells us, well, which angles go together, which sides go together. And so with number 4 here, we're going to use the similarity statement. That's what this is a similarity statement to say what corresponds together. Well, what's nice is I'm literally just going through piece by piece of this statement. So for example, angle K lines up with angle K. Angle L lines up with angle Q, which leaves angle M going with angle R. If I want to do the same thing for the side lengths, then all this is going to do is we can follow the order of the letters here. So KL goes with KQ. Yeah, we're just going to use the arrow to say that those go together. I'm actually going to use this statement. If you notice this little squiggle, the little tilde, that represents is similar to, and so we'll just use it to go with our side lengths as well. In the future, we won't always stay it like that, but for right now, we will. So KL is going with KQ. Here, I'm going to erase this stuff. And I can also see LM is going with QR. And my last pair of side is actually here. KM goes with KR. And so that's how we can read a similarity statement and use it to our advantage. So instead of going through the rest, we're just going to put everything together to find missing lengths. Okay. Here's something I'm actually going to point out up here. Looking at part B here and looking at my similarity statement, I see that side LM goes with side ED. Something I notice about those two lengths, in triangle LMN, 22 is the smallest side. Between 22, 33, 39, 22 is the shortest. Well, in DE, 14 is the shortest of that triangle. If I come and look at LM at 39, and that goes with EC at 22, well, hey, 39 was the longest piece of that first triangle, and 22 is the longest piece of the second triangle. And so something that helps me a lot when I'm trying to decide which ones go together the shortest goes with the shortest, the longest goes with the longest. Because if I'm just multiplying everything by the same scale factor, if it was the shortest side and everything gets multiplied by the same thing, it still stays the shortest side. And so that's just a way you can also check yourself with all that. Okay, so given the two figures are similar, we're going to find the missing length. Well, I have some pieces here. I see that JK is going with TU, so it's going to go with our question mark. And then I see that LK, or KL, is going with UV. And so here's what I can do. If they're similar, that means they've been multiplied by the same scale factor. So how about we just find the scale factor? For my green pieces here, we're going to have to come back to that because I don't know. But I know 54 times my scale factor is going to get me to 12. So I can divide both by 54. I'm going to pull out my calculator. 12 divided by 54. And I get 0.222 repeating. Now here's what I want you to do. In your calculator, when you get that, I don't want you to type out 0.22 again. I just want you to immediately go and do 0.22 and then just hit times 90. And so this should show up in your calculator as answer times 90. Because that way you don't have to worry about rounding, because otherwise it would not be an exact answer. And we get 20 as our missing length. Or if I had just done 90 times 0.22, it would have given me 19.8, which is incorrect. So be sure that you're utilizing your calculator to really use the answer function. So that way you don't have to round. Okay, let's do it again. Let's look at our next example. So if I'm looking at KU, it's over here, which means it's going to line up with UV. And now I have UW and UL. So that means I can find the scale factor. Let's see, I need to get 98 times something, which tells me that I need to keep that direction the same and go 84. I need to find the scale factor that gets from 84 to 18. We want to keep the direction consistent, which is why I did that. So 84 times the scale factor gets me 18. I can divide both by 84. And I get 0.214, blah, blah, blah. And once again, now we don't want to round in the calculator. And so I'm just immediately going to go times 98. So take that and now times 98. And it should get me 21. Another way to avoid this is if you don't want the decimal, you could also leave it as a fraction. And then you can multiply it. So here I can say k is just equal to 18 divided by 84. So I'll just write that out. So I can say k equals 18 over 84. Which is 3 over 14. And then I can just do 98 times 3 over 14. And that's another way that you wouldn't have to worry about rounding as well. Point is, don't round your scale factor. Do not. Okay, so now we're going to make it a little bit more interesting. We're going to involve some variables now, because why not? It's so fun. Okay, let's start with ED, or DE goes with ST. And then we have DC, or CD, going with RS. So I can do the same thing here. Treat this 3x plus 1 as your unknown. I need to go 30 times something is 75. Divide both sides by 30, and I get a scale factor of 2.5. Oh, thank goodness, something nice. Which means that 16 times 2.5 is going to equal 3x plus 1. So whatever that gets us, 16 times 2.5, so 40 is equal to 3x plus 1. Well, this is great, because now I can just solve for x. So I can subtract 1, 39 equals 3x, and we get x equals 13. This is define the missing length, so we can use x equals 13 and then we can plug it back in. So I can say st is equal to 3 times 13 plus 1, which we actually already did over here to get 40. So if you need to find it, you can just plug back in. Let's do another example with D. So RS is going with ED. So this time we want to find the scale factor from the bottom to the top. And that leaves QR with FE. So 30 times my scale factor gets me 225. 225 divided by 30, 7.5. Oh, another nice kind number. That's good. So that means I can take 16 times 7.5, and that's going to get me 26x minus 10. So it gets 120. Great. Can add 10. And now we can divide by 26. And I get 5. All right, I'm gonna pick up in another video so it's not forever and a day long.